Assalamualaikum everyone. I hope you guys are doing well. Today I'm starting a new series that is MYP chemistry, and I hope that before your exam next month, I'll make sure कि आप लोगों को मैं maximum past papers करवा दूँ, and so that you're able to attempt these papers. And of course, if you need any help, I am always available. And let's get started. So this paper is from Assess Prep. So Assess Prep is a very popular platform which makes papers for students. It's an e-assessment that I will be solving, but I have taken a printout of this so I can easily solve on this. There are videos in here that I will be sharing links with you in the description and on the chat as well. Alright, so वो हम कर लेंगे, and inshallah we will all master this. Inshallah we'll do very well in the e-assessments next month. Hareem, thank you for joining. No, this is for MYP, and right now O-levels की इसके बाद में I will be doing another session for O-levels right after this one. Alright, so let's get into it. As you can see, every paper is 100 marks, and there are 4 criterion: A, B, C and D. And criterion A is all about the knowledge and understanding that you have, so that is criterion A. Criterion B is all about learning how to design an experiment. Criterion C is learning how to evaluate the results of an experiment, and criterion D is all about the applications of chemistry and how chemistry allows us to deal with the natural world around us. Alright, so let's get started with this. Section 1. This task addresses the key concepts of change, which is one of the major keywords in MYP, and focuses on criterion A, knowing and understanding. In this task, you will examine the change in elements and compounds of organic and inorganic chemistry. Alright, so what does it say? Polymers are substance or material consisting of very large molecules called macromolecules. That's a technical term. Composed of many repeating subunits. So repeating subunits, you should be able to identify them. We know that polymers are of 2 categories, condensation and addition, and that is all the knowledge that should be coming to you when you read this. Isoprene is an unsaturated, that's a key word. This usually they ask us for the definition of it. So unsaturated means that it has carbon-carbon double bonds, at least one carbon-carbon double bond, could be a triple bond as well, but has to be at least one. That is produced. Similarly, there is this word hydrocarbon. Sometimes they ask you for the definition of that. So hydrocarbon are compounds that are made of hydrogen and carbon only. Alright, that is produced by many plants and animals, and its polymer is the main component of natural rubber. In its pure form, it's a colorless, volatile liquid. So this is telling us a lot about the properties of this thing. Because it's volatile, that shows that its forces of attraction, the one that it has, they're easily broken down, and it needs very little energy to evaporate. Similarly, liquid tells us that this one has a low melting point, which means at room temperature it's easily a liquid, which clearly shows another proof to show that the intermolecular forces that it has, they are very weak and easily breakable. Yes, Abdullah, addition is one of the different kinds of polymers. Alright, so here we have a compound. Now this is a skeletal formula. The key about skeletal formula is that every corner here, 1, 2, 3, 4 and 5, that shows a carbon atom. Similarly, we know that in organic chemistry, you need to remember HOCN or HONC in that order, because hydrogen makes 1 bond, oxygen makes 2 bonds, nitrogen makes 3 bonds, and carbon makes 4 bonds, no more, no less. Right now, this is a carbon atom with 1 bond. That means it has 1, 2 and 3 more hydrogen atoms joined with it. But this carbon atom, as you can see, it has all the 4 bonds that it needed to make. So this one has no hydrogen with it. This one, it has 2 bonds made already, so that means it has 2 more hydrogens with it. So these, I call these chicken feet. So you must draw these chicken feet to figure out how many hydrogens it has. Of course, you can do without it, and you can just count, okay, this has 1 bond, this has 2 bonds, so the remaining from 4, that's how many hydrogen it has. But this has just hydrogen and carbon, which makes it a hydrocarbon. Okay. Line structure of isoprene state the IUPAC name of isoprene, and this is a 1-mark question, and you have to give a name. They said state, which means you don't need to give any reasoning. So that's a command word. Always pay attention to command word when you're solving a paper. Alright, so let's see. First of all, let's try to figure out the main chain that we have. Main chain is the one that has maximum number of carbons and it has the functional groups that you're looking for in the compound. This one is an alkene. It has double bonds between carbons, which means that we are looking for a branch with maximum number of carbon atoms and it must also have the double bond in there. So I think this one is my main branch, and being a main branch, this has, I can see, 4 carbons, which makes this bute. So that's 4 carbons in the main chain. Then it has a double bond, 2 double bonds, which makes it ene. And since there are 2 of them, this will be diene. And then I have to now figure out which carbons have the double bond. So I could start from here or I could start from here when I'm counting these atoms. Where should I start depends on which option gives me smaller numbers. So let's start from here. Let's say this is my first carbon which has a double bond. Then second doesn't show that. 3 double bond. So I can say it is bute 1,3-diene. Okay. Similarly, if I start from here, this is 1, 2, 3. So I have the first double bond encountered here and second double bond encountered here. That's 1, 3. So no matter which side I come from, this is 1,3-diene. Then I also have this branch, and this branch is on, if I come from here, it's on the 3rd carbon, and if I come from here, it's on the 2nd carbon. We always go for the one with smaller numbers, which means I will go for this side, 2. So this is 2nd carbon is where the branch is at, and then this is 1 carbon, so 2-methyl. And there you go. Isoprene's IUPAC name is 2-methyl bute 1,3-diene, and that is what I'll say. Alright. No, Abdullah, this is for MYP. So MYP students are supposed to know how to name these things, but O levels and IGCSE people are not. Alright, identify whether isoprene is saturated or unsaturated compound. So first you have to identify, which means you just give 1 or 2 mark answer that whether it is or not. And then you have to justify it. Justification means you have to give a reason, right? So we'll give the reason that first of all, it is not saturated. It is unsaturated. So that's a 1 mark that I just secured because of carbon to carbon double bonds, and that is my 2nd mark. I can also say that double bond is why it has carbon-carbon double bonds, and that's why it's unsaturated. Again, it's up to you how you do it, like how you phrase it, but just make sure that you use these words and you give a reason, because this is a 2 mark question for that. Okay, this one, determine the product for the following chemical reaction, state the name of the process. Alright, so first of all, let me write the equation for this. I just have to complete the equation. I can see from here that this is an unsaturated hydrocarbon. It is an alkene. How do I know? All alkenes are, they have the number of carbon is N, then they have double the hydrogen, which means CnH2n. And this one is C4H8. So most likely this is alkene. It could also be cycloalkane, but they won't react with hydrogen. This one will. So C4H8 plus hydrogen makes, this is clearly an addition reaction, so C4H10. So I have determined the product. Okay, next state the name of the process. So the name of the process is addition reaction. Okay, but at the same time it is addition of hydrogen, so I want to be more more connected to the answer, more relevant answer. So that's why instead of just saying it's addition, I will give a more specific name that this is hydrogenation. Okay, you can give addition of hydrogen as your answer, or you can give hydrogenation as your answer. Butylene, again bute means 4 carbons, ene means double bond, is a colorless gas. It's a gas which clearly shows that it has weak intermolecular forces, that is present in crude oil as a minor constituent in quantities that are too small for viable extraction, which means we don't spend too much resources on separating it. We just mix it with some other compounds and we just get it as a mixture. Based on your knowledge and understanding, describe. So description means you don't have to give a reason, but you have to detail out how this happens. how butylene will react with steam in the presence of phosphoric acid. We know that butylene has a double bond, and in presence of phosphoric acid, it will undergo hydrolysis. Sorry. Write down the chemical equation for the reaction along with the structural formula. Okay, so structural formula, we'll just write it down. So butylene is C4H8. Okay, and with water it will undergo hydrolysis, and that will be C4H9OH. But since I need to give a structural formula, I will show that it is CH3 CH2 CH2 CH2OH. Now, how did I know this? I can show the equation for this using displayed formula. So I know that butylene has 4 carbons, so I just draw them. Then any one of these must have double bond. Usually for butylene, we'll just put 1 on the first carbon. And now you have to make sure that every carbon gets complete 4 bonds, which means if it has 2 bonds already, you give it 2 more hydrogen. If it has 1 bond already, you give it 3 more hydrogen. You just have to make sure the total bonds at 4. The first carbon has 2 bonds, so I'll just put hydrogen and hydrogen here, 1 bond here because it already has 3. This one has 2 bonds, so 1 and 2. These are hydrogens. And this one is again 3 hydrogens. Add it to water, and now I will get 4 carbons again, and one of them on the double bond will get OH and the other one will get H. So addition reaction is when you break the double bond and you give 1 on each of these. Okay, so here you go. So it's up to me which carbon I give OH and which I give H. So let's say I give OH to this. Now in this case, this will be but because of 4 carbons, 1 ol. I could also give this carbon a hydrogen and this carbon an OH. In this case, it will be but 2 ol. But that's fine. It's totally your choice which one you give an OH and which one you give H. But just make sure you draw the rest of them if you're drawing this. So in your exam, this method is also acceptable, and this one is preferred because they asked us for a structural formula. So if you give this, of course, it will be hard to draw it, and I don't want you to spend too much time drawing it. I would suggest that if you try to draw it here as this, okay, that will save you a lot of time. We have drawn the chemical equation, we have given the information, and this will of course be happening with phosphoric acids. We also need to know what other conditions are there. So usually this is with 300 degrees Celsius temperature and 60 atmospheric pressure. All right. Can you please upload the organic chemistry videos? Which syllabus are you talking about? Are you talking about MYP or some other syllabus? Alright, so this is a video on isotopes. I'll quickly share the link with you in the chat, and if you're watching a recording of this video, you can pause this and you can just go to that link. Okay, so here's the link in the chat. Okay, so you can watch this later if you feel like. Okay, let's see. Video transcript is here. There are 2 people talking about isotopes. Let's see what are they saying. If these people think a small cup of water is enough for after a 10-kilometer run, the zombies must have eaten their brains. My head feels heavy, I need more water. What are you mumbling, Jeff? You need heavy water. Heavy water. Okay. At this rate, I'll take any water. Help me, Alex, I need your blood. Don't be such a drama zone. Funny that you mentioned heavy water. Do you know that if we replace the same volume of water in this bottle with heavy water, it would actually be heavier? Interesting. Are you sure? Both are just water, which basically goes to show that both have just the same chemical properties. How is that possible? I foresee that we are about to discuss isotopes. Get it to the isotopic. Okay. State the formula of heavy water. Identify the isotope of hydrogen which is present in heavy water. Again, they've already told us that it's just water. It's the same thing, which goes to show that chemically it's the same thing, right? But there is 3 isotopes of hydrogen. One of them is H1, one is H2, and one is H3. This one is hydrogen, this is deuterium, and this one is tritium. So this one is usually mentioned as D. So this one is just written as H. So usually when you write water, you don't say H2O, and there might be a confusion at which isotope you're talking about. So instead of saying H2O, we call it D2O. So D2O basically means that it's hydrogen with one neutron in every atom. Okay, so the isotope, because they asked us to identify that, so isotope is deuterium. Okay, so that is why water is heavier. Every atom of every atom of hydrogen has one neutron, which obviously makes it heavier. The following table provides information on the isotopes of oxygen. Complete the table. Alright, so what do we know about isotopes? We know that isotopes have same proton number, different number of neutrons. What that means is that they're heavier, their densities are more, and their chemical properties are still the same. Why? Because the chemical properties depend on how many electrons they have in the atoms, and the number of electrons is the same because they're still the same atom, same element. So only the mass is more. So let's see. Oxygen 17, oxygen 16 and 18, the 17, 18 are basically the mass of that isotope, and the electrons are still the same, 8. But the number of neutrons is going to be more. Why? We're going to subtract the mass number and the number of protons, and that will give us the neutrons. So this one has 10. Okay, alright, so what is the symbol for this? So this is a misprint, I think. It should be written as O17 and 8 here. Similarly, this one should be O16 and 8 here. The bigger number is mass number and the smaller number is proton number. So for this one, it's going to be 18 and 8. Abundance. For abundance, we know that the total is 100%. If this one is 99.76 and this is 0.20, I'll just add them all up. So 99.76 plus 0.2 is 99.96, and I subtract that from 100 and I get 0.04%. That is the abundance of this oxygen 17. We need these abundances because we want to figure out the relative atomic mass. List down some of the harmful impacts of radioactive isotopes on human body. So these radioactive isotopes, what they can do, since they carry a lot of energy, if your skin is exposed to it, the skin can burn. If they have a lot of energy, they can penetrate through the skin and they can damage the DNA. So they can basically make some alteration in there, some mutations can occur because of this. They can also disturb the cell and cell growth, which means they can cause cancer, okay, and even heart disease if they get to that. So you just have to mention some of them. So this is a pretty horrible process. So we have to take care of whenever we are working with radioactive substances. So you can say that they can cause cancer and cardiovascular diseases. But of course you can talk about skin burns and all that. Okay. When an iron nail is immersed in a test tube, so this is a completely different question now. In a test tube containing, okay, before we move on, I want to talk about how we can use this information here to find the relative atomic mass. Okay, so relative atomic mass is AR, and how we find that is we basically multiply the percentage abundance that we have here with the mass of any isotope, and then we add it all up. So although this is not a question, this is a concept that you should know about. So we'll just multiply 99.76% with 16. Similarly, 0.04% by 17, and then 0.2% by 18, and then we add everything up, and whatever answer you get from this, that's going to be your AR, or relative atomic mass of oxygen. Okay, don't worry, in the exam they'll give you the abundance, you don't have to memorize anything. When an iron nail is immersed in a test tube containing copper sulfate solution, the color of the solution changes and a brown deposit is found in the surface of the iron nail. Why is this happening? You have copper sulfate solution, that's the compound you have, CuSO4, aqueous, because it's a solution, and you added iron to this. I'm assuming there is no impurities here. Now this is going to react. Why? Because we know that iron is more reactive than copper. There is an electrochemical series that you need to know about. You need to remember this. I'll quickly write it down here. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper. This is a list that you all need to remember in that order, because this is how the main metals are, and this one is the most reactive, and as you go down they become less and less reactive. The order is important because anything that is more reactive can displace the thing that is less reactive. So if you have calcium atoms and you have aluminum ions and they react, calcium can give electrons to aluminum, reduce it, and calcium can become oxidized. And that's exactly what's happening here. Iron is high up in the reactivity or electrochemical series, and copper is lower. So iron can give its electrons to copper. Why? Because copper is in the ionic form. It's part of the reaction, part of the solution. And iron is an atom. So iron can give electrons to copper, become oxidized, and copper will become reduced. And copper will just be copper element, right? So that's what will happen. Copper will simply change to, this is solid, but now iron will make ions, which will take the place of copper here, and copper will be pushed out. So iron will become aqueous and copper will become solid. So let's see what happened here. Before the reaction, you had iron solid, which is this nail, and you had copper sulfate solution, which is the blue solution here. But after the reaction, this iron nail is deposited with this brown solution, solid, that is this copper. And iron sulfate, we know iron 2 is usually green, that is the green solution that you see here. So this is a clear indication that iron is more reactive than copper. If you put copper here, it will not react because copper is less reactive. Copper can't give its electrons to iron ions, but iron can give its electrons to copper ion. Formulate a balanced chemical equation. We have already done that. Okay, so this is my chemical equation. Identify the type of reaction involved. This is substitution. Now it is called substitution if it happens in organic substances. For inorganic substances like this, we'll just say it is displacement. Okay, moving on. Calculate the mass of ferrous sulfate, so that is FeSO4, produced in the above reaction in grams. Okay, so what mass of copper do we have, or iron do we have? Okay, so we have 8 grams of it. I don't know why it's not mentioned here in the question, but it is 8 grams that I'm seeing here. So calculate the mass of 8 grams of ferrous sulfate. So that is the iron that was 8 grams. Above in the grams. Also state the mass of ferrous sulfate produced in kilograms up to 2 significant figures. Alright, so I start with 8 grams of iron. Okay, I have this equation. Iron plus copper sulfate makes copper plus iron sulfate. And I can clearly see that the equation is balanced, 1:1. That's what I see. Now there are multiple ways of solving this. I'm going to go with the most popular method, which is a 3-step process. Step 1, we will try to figure out how many moles of iron we have. So number of moles of iron, that is 8 divided by what's the AR of iron. Let me see. You will be given a priority table in your e-assessments. You can just find it on, like, there's a button for it, you can just click it and it will open up. But I'm using another one, which is this website. So this tells me that iron is 55.85. So 55.854. That's the one that I have. Okay, so I'm going to do that. That gives me a very small value. So that is 0.1432 moles of iron that I have. So this is usually the first step. Second step, based on this and using the equation, you find out how much of iron sulfate is made. Okay, so because I have 1:1 mole ratio, so if this is 1 mole, this will also be 1 mole. But if this is this many moles, that will also be this many moles. So that's also the number of moles of iron sulfate. So we figured this out, that is 0.1432 moles. Now I need to find out the mass of ferrous sulfate. For that I need to find out what the molecular mass or formula mass of iron sulfate is, or ferrous sulfate. So I'll just calculate that. Iron is 55.854, sulfur is 32.06, and I have 4 oxygen, so 4 times oxygen is 15.999. Okay, so that gives me a total of 151.91. So I'll say that MR of ferrous sulfate is 151.91. So the mass is going to be the given mass or the moles. So moles is 1.1432 times this. So I'm getting 21.75 grams. There you go. Now they asked us that find the mass in kilograms. So I'll just divide it by 1,000. So in kilograms, I can just divide it by 1,000. And they asked us to write it in two significant figures. So this is almost equal to, I'll just say 0.022 kilograms. I rounded it off because I needed to give just two significant figures. Okay, so there you go. That's what I have. Question is that do we need to memorize properties of common gases like ammonia, sulfur dioxide and hydrogen? There are facts that you need to remember about each one of them. As far as solubility is concerned, neutral gases are usually less soluble. Like oxygen is partially soluble, nitrogen is even less soluble, hydrogen is even less soluble. But any gas that is acidic or basic, it is much more soluble. As for what facts you need to know and what things you need to memorize, I have prepared a document. I'll quickly share that in the chat. Just a minute. And there you go, I found it. Here you go. So this is a fact sheet that you can, this is a very good document, spent a lot of time making this, and just do solve, like read through it multiple times before your exam. Alright, select the element which can displace copper from copper sulfate in the solution above. Any element that is more reactive than copper, because copper is in the ion. So that is zinc. Zinc is more reactive than copper. Investigation skill. This task addresses the key concept of relationships, which is again a common theme, an important theme in MYP, and focuses on criterion B, inquiry and design, and criterion C, process and evaluation. In this task, you will investigate the relation between elements of the periodic table. Alright, let's get started. The periodic table, also known as the periodic table of elements, is a rows and column arrangement. What does the row tell us? Row tells us the period number, which tells us the total number of shells. Similarly, columns, that is the group number, and this tells us how many valence electrons we have. That's what we know from this. Alright, so far that's what we have. Let's see. Lothar Meyer, a German chemist, proposed that in arranging elements in the increasing order of their atomic weights, similarities appear in physical and chemical properties. Okay, and regular intervals. No wonder this is called a periodic table. Robert, a student of St. Peter's School, wanted to check for the validity of the hypothesis and compiled the data of atomic mass and atomic volume. So, hypothesis is that if we arrange them in increasing order of the atomic weight, we will see trends and similarities in chemical and physical properties after regular intervals. Okay, so we have this here. As the atomic mass increases, you can see that they don't have access to, like, they have not mentioned the atomic numbers, they have just mentioned atomic masses. And the atomic volume, it shows some change. So like, I can see that this is increasing and then suddenly there's a decrease. Then it's very erratic, like this is pretty similar and then suddenly there's a drop. I don't see many trends, to be honest. Yep. Select the most appropriate graph to represent the periodic trend of these elements. So what should be the most important graph? Like, you have individual data points. You don't have a continuous data, right? You have these. So I personally would go for line graph, because this way we can have a lot of different options. But bar graph is always a good choice, so you could go for bar graph or line graph. I think both of them will be acceptable answers. Use the compiled data of atomic mass, atomic volume, and present the data in a graph. Label the x and y axis. Okay, so we will have to enter all of this data in the graph, and we will be able to easily figure this out. Alright, so we can easily put this. All you have to do is put the atomic mass on the x-axis and volume on the y-axis, and you will be able to see the values. Okay. Using the data, state why alkali metals occupy the peak position. So that clearly shows that they are the biggest atoms because they have the greatest volume. Okay, and why is that? That's what we have to say, that they have greatest volume. Basically, we're saying that in these atoms, alkali metals are always the bigger ones. So just one way to improve the validity of the data. He has measured what? A little over 20 elements in pure devil, which has over 100 elements. So I think the data points are very small. We should include more data points. So I can say that increase the number of elements used to study this. List all the halogens from the data. Again, halogens are the ones that are in group 7 or group 17, depending on how you were taught. So we'll start with fluorine, then bromine and chlorine. So I think there's 3 of them, and we'll just list them all. So fluorine, chlorine. So this is fluorine, chlorine, bromine. You don't need to put them in that order. It's up to you if you want to, but you won't lose marks if you're not. Okay. So that question is done. A displacement reaction is the one where a more reactive element displaces a less reactive element, as you saw in the iron and copper sulfate reaction. So I'm going to share this video link with you, just a minute, so you can watch it. If you're watching this online, you can pause this video here, go watch this video, and then come back. I'll also post the link in the description, so you can just click on this. Okay. Alright, so this is a lot of detail. A displacement reaction is simply when one element pushes out or displaces another from a chemical compound, which means one is an atom, the other is ion. For example, if a mixture of grey zinc powder, which is atom, and blue copper oxide, in which copper is ion, are mixed and then heated strongly, causing the reaction to start, we see a violent chemical change occur when with lots of heat and light, making red copper powder and white zinc oxides. Clearly what we're seeing here is that zinc is displacing copper. So right now zinc is an element, but at the end zinc is part of the compound. So zinc has changed. Okay. Similarly, over here you can see that what do we have here? Copper powder. So copper was part of the compound, but now it is no longer there. Why did we have to heat it? Because maybe the bonding is too strong, maybe the reactivity is very low. So all of that. Okay. The equation is given. This is a word equation. Look at where the metals zinc and copper are in the reactivity series. So reactivity series, again, zinc is higher up, copper is lower. Zinc is above copper, and so is the more reactive metal of the two. Zinc, being more reactive, can push out or displace copper. Yes. What if we try to reverse reaction? Nothing will happen. Copper cannot give its electrons to zinc ions, but zinc can give electrons to copper ion because zinc is more reactive. Nothing will happen. Nothing will happen. This reaction will not work as copper is not reactive enough to displace zinc from its compound. This shows how we can use the priority. Okay, so we have watched the video, and we'll also see color changes happen. Okay, design a method which will allow you to study displacement reaction of iron and copper. Again, they've already given you a description. They've already given you a detail of how this can be done. You can take a solution of one of them and pure metal of the other one, and see if there's a color change, see if there's a reaction that happens, and if there's not, you see that the metal part is unreactive but less reactive, and the compound part is more reactive. And if the reaction happens, the solid that you have added, this is more reactive, and the compound with the element in there was less reactive. So between iron and copper, what will I do? I'll take a solution of iron, add some copper, see if the reaction happens. Then I'll take a solution of copper, add some iron, see if the reaction happens. Wherever I see change, that's where I know reaction has occurred, and that is safer or whatever. Now, how should you answer this question? It's a 16-mark question, so it's very important that you know how to answer this question. First of all, you should always start by designing a hypothesis, as they've said, a possible hypothesis. So your hypothesis should be testable. Easily, you should be able to link the variables that you have here, okay? And then you should give a reason. So the best format for hypothesis: if, then, because. If something happens, then this follows, because that's the case. For example, I can say that if iron is added to copper solution or copper sulfate solution, iron will displace it because iron is more reactive than copper. Similarly, between silver and copper, if copper is added to silver nitrate solution, again you have to pick something that is soluble. Silver chloride is insoluble, silver nitrate is soluble. So these solubilities, again, there's a video, I'll post the link here. Make sure you watch that video because it lists all the important solubility rules that we have. It is also in the fact sheet that I've shared with you. Solubility. Yes, there you go. So this is the solubility rules, and you can watch this video so that you can easily review the solubility rules. So that's one. You come up with a hypothesis that lists the two variables. The two variables are, one is a metal that we have and the other is color change and everything that we'll see. And the method you will, a list of equipment you will use. Of course, you will need to use some equipment to measure your independent variable. You need something to measure the dependent variable. In this case, we might say that the dependent variable is the data by the colorimeter, because we might see a color change, and the independent variable is which metal you add. So that's just knowing which metal you add. You're not really like measuring anything there. The method you will follow. So again, the methodology I've just explained to you. Write both the reactions that follow after the initial reactions. Of course, this will lead to a reaction, this will lead to a reaction, and we'll see. Safety methods and how you will ensure that the method is safe. So of course, these are metals, and we're just making sure that we have gloves and all that. It's always a good idea to wear gloves. And if you just list that risk, you get 1 mark. But if you also mention why you should use that safety precaution, then you obviously get more marks. So for example, these metal salt solution, they can get absorbed into your skin, can be dangerous. So we can mention that don't do that. Don't wear gloves so the solutions don't affect your skin. That's a really simple process, but it gets you the 2 marks because you are giving what you should do and why you should do it. Okay, so that's always important. Alright, so let's see. What is a good idea to do that? I will pick the independent variable is going to be the metal that I add. Dependent variable is the color change that I see. Okay, so let me just write down. If a metal is added to a solution, or if a more reactive metal is added to a solution and color, or then solution changes color because displacement of ions or displacement reaction occurred. Okay, how we can do this? Okay, let me just write down. So how do we do this? We add iron rod to copper sulfate solution. Then it will obviously show a change in color. We have already seen this in the previous question. And then if copper is added to iron sulfate solution, the color change does not happen because this shows that iron is more reactive. Similarly, add silver rod to copper sulfate solution, the color change does not happen, showing that silver is less reactive. Then add copper to silver nitrate solution, color change happens, and this shows that copper is more reactive. How do we know the color change? We use a colorimeter, which is a very simple sensor. It sees the color changes in the solution, and it just gives you variable, gives you graphs based on the intensity of light that is absorbed or that is reflected. So you can use that. And both the reactions, the two reactions that we'll have is that iron will react with copper sulfate. Always give equations. So it makes iron sulfate plus copper. So you can clearly see that iron has displaced copper. Copper is coming out as a metal. And then copper in silver nitrate will give us copper nitrate. Notice that copper has positive 2 charge, but silver has plus 1. So the formula will change according to that. And then you need to balance this out as well. The reverse of this won't happen. So there you go. I can clearly see that a silver solid is deposited for silver, and a red or pink solid is deposited, or brown solid is deposited for copper. So if you mention all of these things, hypothesis that is testable, that links the two variables, uses the format if then because, list of equipment that shows how clearly you will measure it, the independent variable, the dependent variable, one for each, the method that you use, it correctly connects the independent variable with the dependent variable, shows how you will do this reaction. And then both the equations that you give, they're balanced, and safety precaution, you give it with a reason. There's no doubt you will get 16 marks. Select the most relevant equipment used for the previous experiment and name it. Okay, so previous experiment. I don't want to measure pH. Okay, this might be a useful thing because I can add a solution in this and see the color change happen. So I'll say that, okay, I'm going to use this. What is this? Funnel, I don't need it. Okay, good. So we're done with this. Next question. pH is a scale used to specify the acidity or basicity of an aqueous solution. Acid solutions are measured to have lower pH. Of course, the more acidic something, the lower the pH. So this is a soil pH question. So I'm going to share again soil pH. Video link is in the chat right now. You can see that. All right. So they're talking about pH. We know pH goes from 1 to 14. At 7 it's neutral. Again, all of this at room temperature because temperature contains the pH. And below 7 it's acidic, above 7 it's basic, and at 7 it is neutral. The further away you are from 7 on the scale, the stronger the acidity or basicity is. But closer to 7 you are, weaker the acidity or basicity. What that means is the solution, when you add the acid to the solution, it will not ionize as much. We say it is partially ionized. It's a weak acid or a weak base. Similarly, for strong acids or bases, we can say that they fully dissociate or fully ionize. Okay, and they make those. All right. Design a method to investigate the pH of soil of your garden, playground, neighborhood park, nearest construction site, and nearby farming area. We have 5 places that we need to visit. So of course, this is your variable. This is the place where you get the soil samples. In your answer, you should include a list of equipment you will use. Okay, so what do we want to do? We want to collect the soil from these places. How to collect the soil? You'll obviously need something to dig the soil out. And then you will add it to that. You will add some water there. I'll explain a bit. The variables involved: IV, independent variable; dependent variable; control variable. Again, independent variable is where you get the soil. A dependent variable is the pH of the soil, and control variable is maybe the temperature or the amount of water that you add, or how long you let the soil mix in there. Although that's not that much of an important thing. Okay. The method you will follow, I'll explain in a bit. So you just need to mention that you have all the equipment that you need and everything. Details of the measurement you will take to collect sufficient valid data. So I will measure pH. How many pH values I'll get? Of course, I'll take 3 samples from each site. So that is 3 different pH values. Then I'll take their average. So valid data, of course, then I have to process that, right? How will you make sure your method is safe? I'll wear gloves. So here's one method and I'm going to explain. So here's what we do. We go to these 5 places, we wear gloves, we collect the soil samples, but we can't just collect them from the surface. Maybe dig it down to 6 inches and then collect a little bit of soil sample from each of them. Put it, so sample 1 from ground, sample 2 from ground, sample 3 from ground, sample 1 from garden, sample 2 from garden, sample 3 from garden. Make sure you vary it out of the place. You don't just dig one big hole and collect it from there. One here, one on that side, one on that side, 6 feet away and all that. So we have collected 15 samples now. Okay, my independent variable is where I pick it. Okay, where the site is, like garden, playground, park, everything. Now I have the 15 samples. I now add water. I mix it with water. So I will have to stir it, maybe using a stirrer or glass rod. You mix all of that. You let it stay for a while, and then you use pH probe. So that's again another equipment that you have, and use the pH probe to measure and record the pH of each sample. So maybe the first one from garden, second from garden, third from garden. Put it all in the table. Then get the variables average. Get the pH that's average for this. That will represent your pH for garden. Do the same process with samples from playground, all of that. So now we dissolved it in water, we added the pH probe, and we figured this out. Now that we have average of all of them, we have the dependent variable. We make sure that the control variable we mentioned somewhere, temperature should be the same, volume of water should be the same. Okay. Next step, oh, by the way, water should be distilled water, because if you add some other water, then it also has its own impurities, so it can change the pH. So distilled water, mention that. Then what do we do? Now we draw a bar graph maybe, and we try to represent that data on a graph, although that's not strictly required. You have already seen how the pH is and you have investigated it, and then you come up with why that is happening. Now precautions, always wear gloves. You're dealing with the acidic soil. Why? Because acids, they can create itching and damage your skin. Why take the risk? So do that. And I don't think you need any other safety equipment. Maybe wear lab coat or something, not necessarily required. And yep, that's it. Okay, just make sure that if you mention safety precaution, link it to the hazard that you're talking about. Okay, we don't need an equation for this. Design a table for recording and processing your data. You should select the number of rows and columns and edit labels. The label should include indication of more than one trial. So I was saying that we will take 3 trials. Okay, and columns for independent variable, we have already seen type of soil. Column for dependent variable, pH of soil. Okay, so let's see. I have type of soil here. So my independent variable is here. So type of soil. Okay, my dependent variable is this, pH of soil. But in my dependent variable, I have 3 different samples. So sample 1, sample 1, sample 2, sample 3, and then average. Okay, and this one I'm going to list ground, playground, garden, what else was it, park, nearby construction site, and nearby farming area. So construction site, farming area, and all that. You just make a list. The space is given in your e-assessment. Different crops require optimal pH level of soil. Table below represent the optimal pH level of some crops. Okay, so we have that. That's our data. State at least one crop which can be grown in each of the region. So region A, you have 6.6 to 6.8. So in 6.6 to 6.8, I guess we could draw multiple ones. Like we could do this. Most vegetables, guava, rice. No wait, 6.6. This won't work. Citrus. Yep. So guava, vegetable, citrus. Just mention any one of them. Okay. So guava or citrus. 5 to 5.2. Again, 5 to 5.2. This one, rice, passion fruit, pineapple. So you basically pick one from each of these categories from the table and then you mention that. Okay. Farmers of country X are distressed due to acid rain. Of course, it damages this soil pH. Reduces the yield of crop in their land. Suggests 2 improvements to increase the alkalinity of the soil. So first of all, how do you fix the soil pH? You add organic matter to the soil. That will break down, produce humus, and that will buffer the solution pH. What buffer means is that it makes sure that soil's pH is not going to change that easily. Maintains the desired pH level. But you can't just do that right away because right now the soil is acidic. We first need to fix the soil pH. To do that, we add garden lime. Garden lime or calcium hydroxide, it's a mixture of slake lime and other things. You add that to the soil and that raises the pH to an optimum level, whatever you want. And then once you have that, then you obviously add organic matter that doesn't allow the pH to change that much. So those are the 2 improvements. Applying science, that is your criterion D. Global context is identities and relationship. It changes every year. Do check out about 2023 with a focus on physical, psychological, social development, transition, health and well-being, lifestyle choices. Okay, it addresses the key concept of change and focuses on criterion D. Let me share the link of this video with you. This is about teen health, very important for us, of course, at least for you guys. And here you go. Here's the link. You can pause the video, go watch it, come back to this, and here you have this. These are the statistics. This is about drinking and everything, the issues of abuse of drugs, alcoholism, and then you can just discuss this. This is a pretty straightforward explanation, and I don't think that there's anything that I can tell you more than how to answer this question. So I'll just really tell you what you should include and how do you do that. So first point is that you should include the reason for the rise of substance use among teens. So you should mention from the video and the data why that is the way. You should give a comment on the reason. This could be peer pressure. It could be just to enjoy it or to experiment and see how things go. And at the heart of it, it is all just short-term gain that somebody who's not looking for long-term impacts of this, they're looking for that. So you should talk about the issues with that. Okay, next one, an explanation of how these activities affect their personal and social choices, social life. So of course, talk about the rise of substance. Many students do it, many teens do it because they want to get social approval. Maybe they want to fit into people, and maybe it allows them to make more friends, or how then it affects their personal life. They obviously have become skittish. They they start behaving differently. Their behavior changes, and all of this information is given in the video. Use the video. Don't try to just use only your information. Use the resources that they're given you in the exam, so the examiner has proof that student has seen all of that, instead of just coming up with your personal knowledge that you already know. This one is a lot about getting the data, applying it. Okay, give a detail of the impact of this. Maybe talk about lung disease, mental issues that arise after this, social problems like it leads to violence, crime, financial issues, strong for financial issues. People go into crime for this. Okay, so they resort to crime to gain the resources so that they can avail these things. So talk about all of that here. Then they're saying an outline of activities that would decrease the substance use. So this is important. You are using your brain to figure out that how you can stop this. So maybe talk about at least one reason, but I would suggest go ahead, give an outline of multiple activities, because this is going to be a lot of work. Like this is worth a lot of marks, I think. Okay, so talk about what activities you can do, how it will affect people's personal life, social life. Maybe people are doing these things, resorting to these things because they are lonely, so they should go out, meet more people, start sports, some physical activity that allows them to not focus on this. Okay, so give an account of the activities that will lead you to this. Okay, then wider impact of substance use on the society. Talk about how people are not that motivated anymore. People are more they are not that motivated in life. They don't have that many friends. They are resorting to crime. talk about how it affects their personal life, their social life, and how it affects the society in general. So, and then concluded appraisal that how we can do it, why this rises, what to do to stop it, and why we should care about these people because they are part of our society, right? Alright, moving on. Any other thing? Okay, identify and draw one functional group from the glyphosate. So OH, but this one is also with C, so this is COOH. This one is a secondary amine, so that is NH. This one is OH, and this in, you can also say POOH. Although the detail of all of this is not strictly required in your syllabus, but I would suggest just pick this one, which is the most common that you know, or this one, or this one. Like any of these would work. So identify, so carboxylic acid, and that is C double bonded ONH, or amine and NH. And always mention R here. R shows that it could be anything. Just don't leave it hanging, okay? And yeah, those two are good. Okay, we have herbicides, fungicides. I think this is also great. Criterion D and all that. Use the information to calculate the percentage of fungicide in use and the percentage of pesticide used in soybean. Okay. So let's see. For soybean. Alright, so first of all, we have to see that herbicides are 16, this is 4, that's 65. So you add everything up, that is I think 85. Yep, so this one is 15%. So that's one of the answers. Similarly over here, we add everything up and we get soybean when we subtract from 100. So 6 plus 18 plus 9 plus 13 plus 18 plus 26. That's 90% minus from 100, that's 10% soybean. So that's easy. Okay, graphs, more graphs, more graphs. Okay, again, just read through this. D, I already explained to you how you should answer this. Talk about data, talk about these points, and make sure you, it's a 10 mark question, so divide everything 2 lines for each of these points, and at the end make sure that you have reviewed it. That's very important. Many students, once they're done with writing it all, they don't review it. Make sure that you have touched upon each of these points, and I think you will do marvelously well. And with that, my first e-assessment recording for you guys is done. I will see you in the next class. We will do another one of these, and yep, wishing you all the best. If you need any questions, if you have any questions, there is a WhatsApp group for MYP chemistry support. Make sure that you join it, and I'm here in case you need any help. Alright, good luck. Allah Hafiz.